Okay, Assalamualaikum and a very good day, everyone. Hi, I'm Dr. Haslina. I'm from the School of Computing, and I'm one of the lecturers that is teaching C programming or Programming Technique 1 in your school. The other lecturer is Dr. Nur Hidayah, and she is teaching Section 2. I'm teaching Section 1. All right. Now, today I'm going to record this lecture to cover chapter 1. So this is the first chapter in our course, and we're going to cover Introduction to Computers and Programming. Right. So in this chapter, you will learn about the basic computer concepts, the different types of programming languages in general, the elements of a typical C program development environment, and let's get on to it. So this is the outline. So basically we have 1, 2, 3, 4, 5. 5 parts. Well, basically four parts that we're gonna look, and the fifth part is the summary, right? So let's get on to it. Introduction to a program. So here we see three keywords or three concepts that we need to understand. The first one is computer, second is program, and the third is programmer. Now let's just have a look at the picture here. Here we have, I'm sure all of you know, right? So this is a picture of a computer. So we have your computer tower here, contains your CPU, right? And you have your monitor, your keyboard, as well as your mouse. What about at the back here? So here we see, I think this is a word cloud, yeah? So we have C++, C Sharp, Java, Oz, Clarion, Python, right? So these are all the names of programming languages, right? And how about this one? So here we have, this is a cartoon of a man. He's thinking about writing if x minus 1 then. So this is a programmer that's thinking of writing a program which will be inserted into the computer. So the computer then reads the program, and then it will do what the program tells it to do. What about this one? So here we see hash include stdio hit.h. So this looks like a snippet of a code, and this is C, right? So okay, so these are the official definition. Okay, so computer is a programmable machine designed to follow instructions, right? And the instructions are in a set, it's in a program, okay? And the programmer is the person who writes instructions. So by the end of this course, or maybe even by the second or third week, you learn how to be a programmer, okay? Right? So without programmers, there's no programs, and without programs, a computer cannot do anything. All right, so this is the fifth slide, and this figure shows how programming is used to solve a problem. So let's have a look here. Here we have a problem, all right, and we want to go to the end here. We want to solve this problem. So in the middle here, in this purple box, we have two boxes, right? So the human instructions, and then here we see a sequence of numbers, and it's just made up of ones and zeros. So programming language, so we have basic, VB, Visual Basic, C, C++. This is how we can solve a problem, okay, by writing the human instruction, and then it will be translated into ones and zeros, which is what your computer understands. So it cannot understand the natural language that we're talking. So we cannot just say, oh, hey, computer, do this or do that. Well, basically, if you have Siri, you can do that, but it actually goes through separate things. Okay, so that's natural language processing. But now we're just going to learn about C, right? Okay, so this is another figure. So it's actually a more detailed part of the previous figure. So this is the general process to solve a problem using a computer. So here we see that we have a problem and we need to solve it. Okay, yeah, this is the solution here. All right, so to get from this point to this point, okay, so we write the algorithm. So let's just stop a while and look at this green box. Okay, so algorithm, so we see there's step 1, 2 and 3. So I guess algorithms are actually steps, okay, that we use to solve a problem. Okay, and then from the algorithm, then we get a flow chart. Okay, it starts, and then this is whether we want to make a decision, yes or no, and then it goes to the next one and to the end, right? And programming language here again. Okay, so if in the previous slide we see that is human instruction, here we see that it's made up of variable if, for, print. So this is actually what we're going to learn in this course. Okay, how to write programs. So this level of program or this level of instruction is in human, well, something that we humans can understand, you can write and we can read it. Okay, but then these instructions or this program will then be sent, okay, will be translated into ones and zeros, because that's the only language that your computer understands, right? Okay, so the programming language, and then you get the solution. Come back. So now we're going to look at the second part. So we're going to look at computer systems. There's going to be an introduction, and then we're going to look at what are hardwares, what are softwares, and then we will look at the data hierarchy. Okay, let's get on with it. Okay, so the first part, which is the introduction. Okay, so computers can perform computations and make logical decisions faster than human beings can. Of course, we all know this. Computers can make calculations much more quickly, and they don't do mistakes like us humans. All right, and computers can do billions of calculations in 1 second, right? But then here, what about supercomputers? All right, so if computers can perform billions of calculations in 1 second, supercomputers can perform thousands of trillions or quadrillions of instructions per second. Okay, now computers process data under the control of sequences of instructions called a computer program. So we saw this term in the previous slide, right? Computers, program, and programmers. Okay, now a computer consists of various devices referred to as hardware. All right, while the programs that run on a computer we refer to as software. Okay, now I want you to focus on this figure because the next figure will look at specific parts based on this simplistic version. Right, so here we see, okay, this is a figure that explains the computer hardware components. So we know that computers have hardware, softwares, right? Inputs and outputs. All right, so if we're looking at hardware right now, we have input devices, okay, which then sends data into a computer, right? Into memory. Okay, so data is stored in memory, and here we have a double headed arrow, which means that the information goes both ways. So data is stored into memory, then is sent to the CPU. So CPU stands for Central Processing Unit. And then, of course, we know from the name, it processes and then it sends information back to memory to be stored. And then information will then be sent out to output devices. Now, let's look at a more detailed version of this figure in the next slide. All right. Okay. So remember the last slide, guys, right? So we have the input devices, right? So here we have some examples of input devices. So we know devices or hardwares that provide input into our computer. So we know all of us have keyboards, right? On our computers, we have mouse, okay? And all right, so these two are the boxes, other input. So can you give an example of a hardware that can be categorized as an input to your computer? Right? So what is it? Okay, an example. Okay, so have you thought about it? Okay, so an example would be right now if we go to a cashier. So a cashier, actually the device which actually counts up all of your what you bought, right? The cashier scans the barcode of your purchase, all right, and then that can be considered as an input device. All right, so that's one down. What about the other one? Microphone. So microphone is another input device because it collects audio and that will be sent into the computer, right? Can you think of any other input devices? All right, so this input device will send data into, so what about this one? Okay, so in the previous slide, this is memory, but here we see two pink boxes here. So we have the main memory, which there says RAM. What does RAM stand for? Don't worry, it will be in the next slide. Okay, so RAM, main memory. Then we have our secondary storages. Okay, so data is then sent from the input devices into memory. So here we have specific memory. So we have RAM, the main memory, and the secondary storage. What's the difference between these two? Okay, we'll look at that in the next slide. All right, so this data is being sent into this memory, into the memory, and then here this double-headed arrow. So information goes both ways, right? So data is then sent to the CPU, the Central Processing Unit. But here we see that the Central Processing Unit is made up of two separate parts. We have the control unit and the arithmetic and logic unit, the ALU. So what does the ALU do? What is the control unit? It's okay. Next slide, we'll look at this. All right. So after the CPU has done its job of calculating, of organizing the tasks, right? Because CPU can be, you can think of it as the brain of the computer, right? Then it will send the processed data as information to be kept for a while in our memory. And then will it stop there? Of course not, because what comes in must go out. So input, output. So here are the output hardwares. So we have monitor, okay, to see what we're working with, printer to print out, right? Speaker, right, for the audio to come out, all right, so that we can listen to it. Other output. Can you think of other output hardware devices? Yes? Okay. So other output devices, let me think. Mm, mm, Monitor, printer, speaker. What else? Hmm. So discuss this in the next session when you have it with your lecturer. Now, regardless of differences in physical appearances, so here it says that virtually each computer can be divided into few logical units or sections. So here we see these numbers. So for these numbers, you can see the references here. Okay. So we know that a computer hardware. So we have the CPU, we have the memory, we have the secondary storage, we have the inputs and the outputs. All right. I'll not read out what it says here. Okay. Okay. Now this is specific to all the parts. So for a CPU, so remember CPU is made up of the two parts, right? So CPU is the administrative section of the computer, right? And it's the computer's coordinator. So this is where the brain is, right? To coordinate, to process things. And it's made up of the control unit, which retrieves and decodes program instructions, and is the coordinator. So you can think of the control unit as like the supervisor. Okay, while the arithmetic and logic unit, or ALU, is where, okay, as the name suggests, for arithmetic and logic, hardware optimized for performing high-speed numeric calculation, right? What about this one? This looks like a wafer. Okay, so this is the main memory. So I'm sure that some of you have seen this before. If you haven't seen it, so this, if you see this, if you come across this, this is a memory or RAM. Okay, so maybe you have heard of your friends saying that they need to buy more RAM to make their computer faster. All right. So if you can still remember from the previous figures, we have two separate different types of memory. So here we have the main memory, and we also have the secondary storage. So here, what I want you to look at or to pay attention to is this word, volatile, right? So main memory is volatile. So what does this mean? It means that, so we know that the input devices will send data that will be stored in the main memory. Okay, but the main memory is volatile, meaning that data that is kept here is temporary. It's called random access memory. When there's no electricity, or when the program terminates, or when the computer is turned off, then all of the data being kept here will be erased, right? All right. So each byte in memory is identified by a unique number known as an address. What does this mean? To the next slide. Now, memory is organized as follows. So we have here bit and byte. So information is stored in bits or bytes. So what is a bit? Bit is the smallest piece of memory. So in computers, that's represented by zeros and ones. So zeros usually will represent the status of off or false, while the number one will represent the status of on or true, right? Now, what about byte? Now, byte is made up of 8 consecutive bits, right? 8 consecutive bits, and bytes have addresses. Okay, so bytes have addresses. What does this mean? So have a look at this figure right here. Boxes with even smaller boxes on the upper left part of the box with numbers here. And here we have an actual number stored in this box. What does this mean? So here we see that the number 149 is stored in the byte 100100101, right? So this byte is at the address of number 16, right? So here, because information is stored in bits or bytes, right? So here we have the address, and this is where this number or this value is stored. all right, while the number 72, okay, with 01001000 is stored at address number 23, right? Okay, next we move on to secondary storage. Okay, so remember when I said that the main storage or the RAM is volatile. Here secondary storage is non-volatile. Let's look at these pictures here first. So here we have the optical discs, so CD-ROM, DVD, right? We have this one. Okay, so what's this? If you haven't seen this before, this is actually a magnetic disk. All right, so this is a hard drive, right? So here, I think now we have two separate types. Okay, so in this one, this is the so we have two types now. We have the solid state drive, okay, which does not have this arm moving about, so the disk will actually move around, will spin, okay, and this arm will actually read through the disk, okay, to read the data stored, okay. And then here I'm sure that students know this, okay, know this well. This is a USB, this is a pen drive, while this is a floppy disk, okay. Okay, so here are examples of input devices. So this is a keyboard, scanner, computer, computer pula, digital camera, all right. This is a joystick, microphone, okay. So all this will send data into the computer, right? So output devices. So actually output is information, so sent from computer program to the outside world, all right. So these are the output devices. So computer monitor, here we have a printer, speaker, as well as a plotter. So this just shows all of the hardware, right, of a computer. Okay, so we've covered hardware. What about software, right? Software is actually programs that run on a computer. Okay, so here software can be categorized into two, right? So we have operating system and application software. So what's an operating system? Basically, it's the program that manage the hardware of the computer hardware and run the programs that run on them. So here we see okay. So this is quite old. Windows 7, Solaris, Mac OS, and Linux. So I'm sure most of students, your operating system would be Windows, as is mine. Okay, but maybe some students, if you have a Mac, right? So your operating system would be Mac OS. If you're running Linux, more power to you. So this is the Penguin, okay? So Linux, and then there's Solaris. Okay, what about application software? So what is application software? So application software are programs that provide services to the user, right? So these are the things that you install on your computer for you to do things on your computer. So Microsoft Office, we all know this, Adobe, and Gameloft. Right. Now, next we move on to data hierarchy. So this is an example of data hierarchy. I'm just going to explain this in this slide. Okay, right. So here we have bit. So we know that bit is made up of 0 and 1, right? So a bit is the smallest item, data item in the computer. Okay, it's either 1 or 0, right? So 1 or 0 is already here. So this is a character. So 16-bit Unicode character, right? So it's composed of bits. Okay, characters are composed of bits. Okay, it consists of decimal digits, zeros or nines, right? What about this one? Right. So here, 1 is part of this character, which actually stands for this field. So these are a group of characters, right? So JUDY. So this is a field, a group of characters or bytes that convey meaning. So here we see that Judy, well, what does it mean to me? So that's just a name, a female name. All right. Now, what about a collection of fields? So a collection of fields here is called a record. Okay, a record, or several related fields that can be used to compose a record. Okay, what about a collection of records? So a collection of records is called a file. Okay, a group of related records. So here are records of names. Group of related record of names are called a file. What about a group of related files? Then that is what we call a database, right? Which is all stated here. I'll just skip this and we'll move on to the next part. Alright, welcome back. So we're now looking at the third part of this lecture. Okay, sikit lagi. Okay, lagi dua je. Okay, so we're going to look at programming languages. So there's going to be an introduction and we will look at the type of programming languages. Right, so from the first number three slide, okay, we know that a program is a set of instructions that we write to tell the computer what to do, right? And the person who writes the programs is called a programmer, right? So the program that we write in, so we can write it in various programming languages. So in this course, you're going to learn how to write the set of instructions in C. All right, so and remember in the first previous slide, we saw that in the elaborate concept of the program, so we saw that we have a problem, we write a set of algorithms. So what is an algorithm? All right, as an algorithm is a set of well-defined steps. Okay, now let's look at example 1.1. Okay, and this is an algorithm for calculating the average of three numbers. Now let's have a look through. So here we see that there's 6 steps, right? And step 1, okay, where this is to calculate the average of 3 numbers. First, we determine the first number. We call it A. Second, we determine the second number. We call it B. Third, we determine the third number. We call it C. And fourth, we find the sum of A, B, and C, and we call it X. Step 5, we divide X by 3, and we call it the result. And step 6, we present the result. Now, let's have a look here. Let's just examine this and see what we can analyze here. So for the first step, so this is a set of well-defined steps, right? So here we have 6 steps, and for each step we state what we want to do, and then we give it a name. Okay, right? So there's what we want to do and then the name that we give it, right? Okay, so this is the first example of an algorithm. Let's have a look at the second example, example 1.2. So this is an algorithm for calculating gross pay, right? So here we have 1, 2, 3. It doesn't look like it's complete, right? 4, 5, 6, all right, right. So step 1, display a message on the screen asking how many hours did you work. Step 2, wait for the user to enter the number of hours worked. Once the user enters a number, store it in memory. Step 3, display a message on the screen asking how much do you get paid per hour. Step 4, wait for the user to enter an hourly pay rate. Once the user enters a number, store it in memory. Step 5, multiply the number of hours by the amount paid per hour and store the result in memory. And finally, step 6, display a message on the screen that tells the amount of money earned. The message must include the result of the calculation performed in step 5. Now, let's stop a while and think about, all right, what are the things that's similar between these two algorithms, and how do they differ? Okay, so think by yourself. And next, during the class discussion time, please discuss this with your friends and with your lecturer. Okay, so we'll discuss this in class, yeah? Okay, next we go to type of programming language, right? So previously we looked at algorithm, okay? So we know that here we see that there's 3 different types of programming language. Okay, so we know that for machine language, it's basically the only language that the computer can understand. It's in binary machine code, zeros and ones directly. Okay, remember the first figure that we saw? Human instruction and then converted to zeros and ones. So we know that computers only understand zeros and ones, which is in machine language. But let's stop and think. Can you write a set of instructions using machine language? Even if I can, I do not want to. Okay, all right. Then there's assembly language. So this is one level above machine language. So this is a low level language that is processor dependent, and each CPU has its own assembly language. Okay, all right. Now the next level is the high level language. So this is closer to human language that you and I can read, write, and understand. Okay, now this sounds much better. All right. So high level programming languages are not processor dependent. Okay, and a program written with this language must be translated into a language that can be understood by a computer before it can be run. All right. So here we see 3 different types of programming languages and the different levels they are. Okay. Okay, here is just a little explanation of machine language. Okay, so as mentioned previously, computer only executes machine language instructions. Okay, and is made up of binary numbers, zeros and ones. Okay, but we as programmers, we don't write programs in machine language. Yeah, we write it in programming language in higher level. Okay, so here we see a hierarchy of programming languages. So here we have the hardware, we covered this previously. And then here, machine language is at the very bottom, okay, made of zeros and ones. Here, okay, low level machine language. Then this machine language, the one level above that is the assembly language. It's processor dependent. And then, yeah, we are interested in this one, okay, the high level language, okay, close to human language that we can read, we can understand, and we can write. Okay, now these are a table of some well-known programming languages. Can you tell me if there's any programming languages that you have written before? I know that some of you have actually learned this during your sekolah menengah or even during your matric. Okay, if I'm not mistaken, Java, yes, all right. So, but now I think with data science, and then with the fourth industrial revolution, a lot of people are learning Python. Okay, so Python is a much easier language to learn, right? But no matter, usually if you are learning a programming language, like the first programming language that you should learn should be C or C++, right? So if you can master one programming language, then you can transfer that skill that you learn easily to other programming languages. Okay, now we move on to program development environment. So generally, C system consists of several parts. Here we see 3, right? So we have a program development environment, and the language, and the C standard library. Now, C programs typically go through 6 phases to be executed, right? Edit, pre-process, compile, link, load, and execute. What does this mean, right? So let's have a look at the figures 15.A and 15.B. So this is a typical C development environment. Okay, so first we use an editor. So we programmers create programs in the editor and then we store it on the disk, right? Step 2 or phase 2, the preprocessor, okay, program processes the code. Step 3, the compiler creates the object code and stores it on disk, right? So all of these are still stored on disks, right? And the linker links the object code with the libraries and creates an executable file and stores it on a disk, right? And next, right? So pay attention. So previously, disk. Step 5, so here we see another new element here. We have a primary memory. So the disk, right? The loader puts the program into the memory. It loads from the disk into the primary memory. And then phase 6. Okay, so here we have the double headed arrow here. CPU then takes each instruction and executes it, possibly storing new data values as the program executes. So it will store new data and value here. It will take each instruction also from primary memory and then processes it here. Okay. Now, phases 2 to 4 are often performed by a single command or button click. Right. So if you just use your IDE, right? So just one click or just one command, it will run all these 3 phases. So errors detected at any step will prevent execution of the following step. All right. Now, next we look at the IDEs or the integrated development environments. Right. So here we have IDE in the middle, and here we have write, debug, translate, run, and document. So an IDE combines all the tools needed to write, compile, debug, program into a single software application. So for this course, we're going to use Microsoft Visual Studio. Okay, but there are other IDEs available. Okay, so we have Microsoft Visual C++, Pollen C++, Code Warrior, etc. Right. So this next slide shows just a snapshot. I used this during my undergraduate, right? So Pollen C++ builder. So here it shows the code, right? Okay. Now, still on the third part, okay, programming languages, what a program is made up of. So here are the common elements in the programming language. So we have syntax, keywords, programmer-defined identifiers, operators, punctuation, and variables. So what does all of this mean? As usual, it will be on the next slide. So here we have the syntax. All right, so what is a syntax? Syntax is where we specify rules for sequence of characters to be written in the C language that will be grouped together to form tokens. Here we have the figure. This is the example of the basic syntax in C programming language. So we have the header files. Okay, hash include stdio.h. Then we have our main function. It should be here, must be here. Then we have this open curly bracket, right? And this one is a single line of comment, right? And if you look here, there's a semicolon after each statement, right? Please pay attention to this. Some of you, when you write your codes, maybe you will get some errors. Usually it will be this. And then programs are enclosed within curly brackets. So the next part is the keywords. So here are an example of keywords. So keywords in a C programming language, these are reserved words. So if you write your own identifier or variables, you cannot use these reserved keywords. Okay, so these are programmer defined identifier. Ayam berkokok sekarang pukul berapa? Okay, so these are programmer defined identifier. So a name used to identify a variable, function, or any other user defined item. So how do you write an identifier? So an identifier can start with capital A to Z, or small letter a to z, lowercase a to z, or an underscore followed by 0 or more letters, underscores and digits. So these are an example of acceptable programmer defined identifier. So here this identifier starts with a uppercase A. This is a mix, uppercase and lowercase, a mix of uppercase character with numbers. So here we have an underscore. This is also acceptable. Lowercase combined with uppercase with numbers, also acceptable. Just a single character, also acceptable. Starts with an underscore, acceptable. Okay, right. Next, we look at operators. So what are operators? Operators is a symbol that we tell the compiler to perform specific mathematical or logical manipulations. Here we see for arithmetic operators, these are the examples of the operators for arithmetic: plus, minus, divide, times. The relational, okay, not the same, larger, smaller, okay, logical, or, and, not. And here we have punctuation. So what is punctuation? So punctuation and special characters have various uses, from organizing program text to defining the tasks that the compiler or the compiled programs carries out. Now here we see that, okay, so these are examples of acceptable programmer defined identifier in C programming language. So take care that some punctuation symbols are also operators. Okay, this one. Okay, and finally, we will look at variable. So a variable is but a name given to a storage area that programs can manipulate. So each variable in C has a specific type, which determines the size and layout of the variable's memory, the range of values, right? And what about the name of variables? It can be composed of letters, digits, and underscore characters. But please take care, because in C, C is case sensitive. Therefore, if for example your variable is Ahmad, A with and starts with a uppercase A, and then you have another variable which is still Ahmad but starts with a lowercase a. So C will treat both as separate or different variables. Yeah. Okay, welcome back. Okay, so we're going to continue with section 1.4 of chapter 1. We're going to look at programming paradigms. Right? We will look at procedural programming and object-oriented programming. What's the difference between these two? Right? So let's start. Okay, now programming is a creative process carried out by programmers which instructs a computer. Well, we've covered this in the first lecture, in the first part of this chapter. Okay, but there are a number of alternative approaches to the programming process where we call this as programming paradigms. So fundamentally, different paradigms represent different approaches to programming. And most programming languages fall under one paradigm. But some languages have elements of multiple paradigms. Now let's have a look. Alright, so there's two, let's just look at two of the most important approaches of programming process. So we have procedural programming and object-oriented programming, or OOP. Okay, let's have a look. Let's inspect this. So this is procedural programming. So let's have a look at this one. So this is the figure. So here we see that this is a program. So that's a main program. All right. Uh, and the main program coordinates calls to procedures. So here are the procedures and hands over appropriate data as parameters. So data here, send it to procedures. All right. Okay. Now, procedural programming is the focus is on the process or it's action oriented. Okay. So procedural programming uses a list of instructions that tells the computer what to do step by step. Okay. And okay, I want you to focus on this. So the unit of programming for procedural programming is function or procedures. Here we see in this figure is procedures, right? So functions and procedures are written to process data. So data is held here, data is sent to procedures, all right? An example of programming languages that uses the procedural programming is C, COBOL, Fortran, Pascal, and BASIC. All right. Okay. Let's look at object-oriented programming. So object-oriented programming is also known as modular programming. Okay. Let's have a look at and inspect this one. So here we have a program. So we have the main program, and instead of a procedure, okay, here we have a module. Okay, we have data plus data plus data 2, and then we have the procedure. Okay, we have separate procedures. So the focus here is on objects which contains data and know how to manipulate data with grouped functionality. So here the unit of programming for OOP is class or module. So in this case is module. So all this is called module 1. Okay, this is called module 2. So messages are sent to objects to perform operations. Okay, sent to objects to perform operations. So an example of programming languages that use the programming paradigm of OOP would be C++, Java, C#, Delphi, and Ada. Okay, now we've come to the end of this recorded lecture. We're just going to summarize everything. Okay, so let's just summarize everything. For this first chapter, you have learned the basic computer concepts. I'm sure that after this, you can actually identify what are the hardwares and what are the different types of hardwares on your computer, what are software, and what are the components. All right, and then we as programmers, we use programming languages to write a program rather than coding in machine language, because machine language is just zeros and ones, right? And the common elements of a typical C program development environment. All right, so let's finish it by looking at this cartoon. So a programmer's life. Okay, so I want you to read through this and figure out the joke. All right, thank you. I think that's all for this first chapter. I look forward to seeing you in class and to have the discussion with all of you. All right. So bye-bye. Assalamualaikum.